Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from 2018, and this is the paper 2, Maths GCSE, so it's the calculator paper. And we're on question 13. So this is a question regarding cyclic quadrilaterals and all things to do with angles in a circle. What we've got to show is that y minus x equals 90 degrees. So we're given y and we're given x. And there's several ways of doing this problem. I often find that it's not obvious how to do this question or questions like this. And so just find any angles that you can, and often you can get to the angle that you're looking for. So one approach to this question is we can see that OD here is a radius. Now, if we to add another radius in here, so if I was to go from B to O, to add another line like that, then what we'd have is that BOD would be an isosceles triangle because we've got BO and OD of equal length because we're both radiuses. So BOD is an isosceles triangle. And because of that, we can say, using the three-letter angle system, the angle here, which I would call DBO, so angle DBO is also going to be equal to x, because the base angles of an isosceles triangle are equal. So we could have to put that in brackets, base angles of an isosceles triangle are equal. Okay, so if we know that that one is x as well, there we go, there's x, then we can actually find this angle here simply through knowing that angles in a triangle add up to 180. So we can say angle BOD is going to equal 180 minus 2x. And again, angles in a circle, putting our reason in brackets. So angles in a triangle, I should say. Add to 180. Okay, so we've got the angle here. Now, there is a rule that an angle held by an arc, so in this case BD is an arc of this circle, at the centre of the circle is twice that held by the same arc at the circumference. So we can actually say that BCD, the angle at the circumference, is equal to 2 times, half, I should say, is equal to half times BOD. So the reason for this is angle at circumference equals half angle at centre. So we can see that BCD is going to be half times 180 minus 2x, which would give us 90 minus x. So we've got this angle here, so we know this one is 90 minus x. Now there's another rule, which is we've got a cyclic quadrilateral here. ABCD is a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral add up to 180. So the opposite angle to this one is y. So we can say that y plus BCD must equal 180, and the reason being they are opposite angles in cyclic, i.e. meaning circle, cyclic quad, I'm just write quad there, quadrilateral equal 180. So if we replace the BCD by 90 minus x, we get y plus 90 minus x equals 180. If we take the 90 over to the other side, we do indeed get y minus x equals 180 minus 90, which is 90. And we've done it. That's it. That's part A completed. We're given a second part to this question, which says that Dylan was asked to give some possible values for x and y. So he says that y could be 200 and x could be 110 because that does fit the rule that we've just said. 200 minus 110 is equal to 90. Now, is he right? Well, he can't be right because the angles in a triangle must add up to 180. So that would mean that y couldn't be more than 180, because that would mean that the angles in triangle ABD would add up to more than 180. So we can say, no, Dylan is wrong. The reason being, y must be less than 180 degrees, since it is part of a triangle. In a triangle. There we go. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel. And for further help, please look at our website, which is bestmathstutors.co.uk. Thanks for watching.